Hey there, this is Mr. Wilford, and I just wanted to go through Chapter 8, Section 1 with you and talk a little bit about similarity in right triangles. We're talking about, in this first section, about right triangles and how they are similar. And the first theorem here has to do with similarity if you break down the right triangles. Basically, we have a right triangle ABC, and here's the right angle. And we have this altitude right here, so we're forming another right triangle, actually two right triangles within the main right triangle. These three triangles, the main ABC triangle and ADC and CDB, those are all similar triangles. And so the first part of this section here, what you're doing is really just taking this triangle, here's an example, and breaking it into the three similar triangles. And just writing it as similarities. The next thing that we talk about here is something called the geometric mean. And if you look at this proportion here, a over x is equal to x over b, if you cross multiply that, what you end up with is this statement right here. This is the idea behind the geometric mean. And we get this little formula, x squared, x times x, is equal to AB, A times B. So there will be some examples here where you're going to want to find the geometric mean given a couple of numbers. So if you just use this little formula here, x squared equals AB, you can see in this example 4 and 9, basically you're taking the x squared, setting it equal to 4 times 9, and just simplifying for x. So x squared is equal to 36. The square root to both sides gives you x equals 6. Then we have 6 and 15, same thing. We just reduce the radical here. Square root of 90 turns into 3 times the square root of 10. As we continue here, we can use that idea of geometric means using a couple different corollaries here. The first one has to do, and really all of these are taking this triangle here and breaking up all the sides and the altitude, which is h. Corollary 812 says that this altitude h squared is going to equal x times y. So if you multiply these sides here together, it's equal to h squared. Then we have 813, and this has to do with the legs of the main triangle, A and B. And if you watch here how this is broken up, side A, if you take A squared, it's going to equal x times C. Now C is the hypotenuse of the main triangle, it's that long side. In the same fashion, B squared, which is this leg here, is going to equal y, this shorter segment here, times C, the hypotenuse of the main triangle. So we can use these corollaries then to take a look at an example here. Really, we're given a triangle, a right triangle. This is the main right triangle, and we're breaking it up with the altitude here. And we're finding all of the sides, x, y, and z. So we're really just finding everything about that triangle. So using that, the corollary is the geometric mean. Since we know this is 2 and this is 10, and added together would give me 12. First thing I want to do is take x squared and set that equal to 2 times 10, which is 20. Take the square root to both sides, I get x is equal to 2 times the square root of 5. Then I can take and find y by taking y squared is equal to 12, which is the sum here, times 10. And again, solve for y there, taking the square root to both sides. And then do the same thing with z. Z squared is equal to 12, the sum, times 2, the shorter side here. Square root to both sides, I get z is equal to 2 times the square root of 6. If you have trouble with these square roots, simplifying the radicals, that's fine. You certainly can use your calculator too to help you out with that. And then finally, there's a couple application problems. If you have any questions, please let me know. Thanks.